today's business world, meetings and learning sessions rely on fast and seamless communication tools. AI is no longer just a buzzword. In the tech world, it's transforming how we meet, collaborate, and learn. You've seen some really cool technologies today so far of how AI is being used, and it's being implemented in smart cameras that track speakers to real-time transcription tools. AI is reshaping the way we connect, just as black and white televisions did in the 50s, and they became a very important learning tool for us. And then we transitioned in the 80s from analog to digital. AI is on that level of importance today. AI is the hottest topic in technology today, according to Google. Internet searches for the term artificial intelligence have increased 20-fold in the last few years. We are bombarded with almost daily by predictions simultaneously proclaiming the end of the world will be brought about by aberrant, self-aware computer programs. And by mimicking human intelligence, AI and machine learning are becoming powerful tools in other industries like material science, medicine, drug discovery, robotics, and even sociology. Concerns around bias, privacy, value alignment, safety, risk, workforce disruption, and even a new term, de-skilling, which is talking about, will AI actually take over my job? But machines will be good at mimicking human intelligence, but they're going to still need a lot of us for most of the jobs that we do. Most people do not fully understand AI. They hear it a lot. We say that we have put it into our products, but there's a lot of fear of the unknown, panic and anxiety, leading people to believe in the worst case scenarios. So let's dive in a little deeper with AI and what it is. And let's see where we can do this. There we go. Back in the days, as I mentioned, of black and white TV, they were revolutionary for instruction and communication. Similarly, today, AI in AV is changing how knowledge is shared, whether in remote learning, virtual corporate training, or hybrid meetings. Back in 1952, a computer scientist named Arthur Samuel actually developed a program to play checkers. That was the first algorithm to play a game independently by a computer. In 1955, mathematician John McCarthy was holding a workshop at Dartmouth College and used the term artificial intelligence for the very first time that we recorded. A generation ago, 1982, compact disc was first released. CD sales grew 10-fold for the first few years, and the word digital was on everybody's lips. Everything had to be digital ready. The AV industry was transitioning from analog to digital, and much like the digital ready marketing hype of the 1980s, today's AI claims are often too good to be true. In reality, AI in AV, especially for meetings and learning sessions, has its limitations. However, the practical benefits, like enhanced real-time collaboration, are absolutely undeniable. Perhaps AI is the digital ready of this age. Today, virtual assistants like Alexa and Google Assistant are used to automate transcription services and capture meeting notes. AI is making meetings much more efficient and accessible, especially with some of the things that you are seeing in cameras these days. What AV-based tools would you think would improve daily meetings, classes, and presentations? You don't have to answer, just kind of think about it. There's a lot of technology today, and some of us have desires of what we could actually do with it. So what can AI do for us now? We're past digital, we're into artificial intelligence. Meeting minutes and summaries are being generated by AI. Key points of the meeting, decisions made, task assignments, and key takeaways are all being handled by AI, can be handled by AI from the discussion of the meeting. Action items and key questions that were addressed in the meeting can be handled by AI. Transcription and playback, providing full transcripts of the meeting, augmented in real time with real-time participant reactions and engagement. Participant level metrics, speaking time, bias, and engagement, including coaching suggestions included in clarity, inclusivity, and impact. It can even give us recommendations on how the presenter can improve speaking pace, limit interruptions, and reduce filler words. It can even report on engagement levels and highlight moments of positive or negative reactions from meeting attendees. This is all capabilities that we can see today. So what is artificial intelligence really? Is it going to destroy us, or is it going to be a useful tool for us? There's several different types of AI. What we're going to talk about today are what those types are, types of AI, categories of AI, models of AI, all very different parts of what our artificial intelligence is made up of. There's supervised and unsupervised training as they apply to machine learning. Object-based recording, video, and programming, where we'll see tremendous impact in our AV world. AI deployment in the service of AV is going to be a huge factor. And in the context of AV, AI isn't just about robots or futuristic tech. It's about smart systems that assist us in routine tasks and arranging the best video call setup to optimizing sound in a training, which we've seen today. AI is making collaboration more seamless. Intelligence is the ability to acquire and apply knowledge and skills. Artificial intelligence is the automation of intelligent behavior through machine learning. There are two types of AI, narrow intelligence and artificial intelligence. I hadn't heard of either one of these before I started working on this presentation. Narrow AI is like what you're seeing in AV systems today. It focuses on very specific tasks, like adjusting lighting in a meeting room or automatically muting background noise during video calls and speaker tracking. While AGI is a general intelligence, is still far from reality. AI in the AV space is evolving. In the future, we might see AI systems that not only adjust the lighting or sound, but understand the flow of a meeting, predict the next agenda point, or summarize key decisions instantly. We're going to talk about some of the things that we'd be able to do in other parts of audiovisual as well. Keep going. Narrow AI is sometimes called weak AI. You'll hear it referred to as weak AI, narrow AI, same thing. It refers to artificial intelligence that is designed to excel at one specific task. Unlike the science fiction vision of AI with general intelligence, narrow AI doesn't have the broad thinking or problem-solving abilities. Narrow AI is trained to perform a single task exceptionally well, like playing chess, recognizing faces, or even translating languages. Knowledge gained from one task isn't automatically applied to others. A program that masters chess would not be able to use that same knowledge to win at a game of checkers, for instance. Narrow AI operates based on defined rules and algorithms. It can adapt or improvise in new situations the way humans can. Most of the AI we encounter today, and I mean most of the AI we encounter today, is narrow AI. Some common examples include simple spam filters, sorting out your email, self-driving vehicles, still narrow AI, facial recognition software, which we heard about today, and it can be used for security purposes. Recommendation systems like on shopping sites. If you buy something on Amazon today, it's going to recommend 3 things that are similar to that for you to purchase as well. That's narrow AI at its best. And voice assistants like Siri and Alexa are based on narrow AI. Most AI you encounter in AV today is narrow AI as well, like automatic transcription software that captures meeting notes, or noise canceling features that filter out distractions during virtual conferences. Artificial general intelligence is also known as strong AI. So we have narrow AI is weak AI, and strong AI is general intelligence. Some argue that current AI systems, even very advanced ones, fall short of true AGI. While impressive, they lack the key characteristics of being able to learn and adapt and apply that knowledge, truly understand the nuance of a condition, and learn entirely new things on their own. In the future of AI, machines achieve human-like intelligence. Oops, sorry about that. This intelligence wouldn't be limited to specific tasks like they are today, but would allow them to learn, reason, and solve problems across a wide range of situations, just like humans can today. Others take the viewpoint that some of the most advanced AI models, like large language models, which we'll get to in a minute, might represent early stages of AGI, but we're not there yet. One of the very first tests that was done with AI is called the Turing test, and it was, again, back in the 50s. And what that did was, it was a test of a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. Turing proposed that a human evaluator would judge natural language conversations between a human and a machine designed to generate human-like responses. The evaluator would be aware of the fact that one of the two is a machine and the other is a human. The evaluator would also be separated so they couldn't see who they were communicating with, and the conversation would be limited to text only, such as computer keyboard and screen. So the test result would not depend on the machine's ability to render words as speech. If the evaluator could not reliably tell the machine from the human, the machine would be said to have passed that test. The test results would not depend on the machine's ability to give correct answers, only how closely it resembles what a human would give. And we hear that all the time today. AI is pretty cool. GPT is pretty cool, but not always 100% accurate. So just be aware of that as you're going through and getting better, more knowledge in artificial intelligence. There's 4 categories of AI. The first category is reactive machines. This is, for an example, is Spotify and Netflix. You play a playlist, and this starts giving you suggestions of other songs that you may like based on what you've played. Same thing with Netflix. And that's really all it can do. That is narrow AI. Then next up is a category of limited memory machines. And they imitate the way our brains neurons work together. This is a good example of this is today's automated cars. Several cities have fully automated cars that they're using in like Uber transportation today. Tesla has said that they're taking most of their R&D and turning it into fully automated cars and getting away from the retail part of that. Next category is theory of mind. It has the theory of mind is the ability to track and infer the mental state of others. Theory of mind in AI will impact human AI interactions and likely increase the trust that we have in the machines. We want to be able to attribute human characteristics to AI, emotions, intentions, relationships to non-human objects, such as animals, even phenomena and technology in today's technology. A common way that humans perceive and interact with the world around them is theory of mind. The last category is self-aware. Science fiction aside, humans have inclination to attribute human-like traits to AI, including bad traits. However, we're nowhere near this type of artificial intelligence today. So that begs the question, is sentient AI actually possible? And the answer is no. The AI systems we have today are incapable of experiencing the world and having emotions as humans do. So for now, any examples of sentient AI exist only in the world of science fiction, and we enjoy the heck out of those movies, don't we? There are two models of AI. Lots of different categories and things to know about AI that you just may not have known. Discriminative AI and generative AI are two different models. Discriminative AI, unlike a curious child, is more like a diligent student following very specific instructions. It focuses on learning the differences between existing categories in data. Imagine showing the student labeled pictures of cats and dogs. A discriminative AI would analyze these pictures to learn the key features that distinguish cats from dogs, allowing it to correctly classify new images that it hasn't even seen before. Even though cats may look completely different from one another, discriminative AI would allow it to know that it's still a cat. Discriminative AI is powered by two kinds of neural nets, recurrent and convolutional. Recurrent, or RNN, is what we get with ChatGPT. It has 175 billion parameters distributed over 96 layers in the neural network. And I won't even get into what all that means, because honestly, I don't know enough about it. But a layer in a deep learning model is a structure, and it takes information from the previous layers and passes it on to the next layer. Take the cat, for example. It'll just keep gathering information to pass on and decide what is a cat, what isn't. And you'll see the term dimensions used in context of data analysis and machine learning. Dimensions refer to the features or attributes of data, like a data set of houses that include the price, the size, the number of rooms, the number of bathrooms, the location. That is dimensions of AI in a data set. Most discriminative AI models are trained using supervised learning techniques. The model is given labeled data, which means the data points have predefined categories or classifications. This allows the model to learn the key features that distinguish between those categories, like cats and dogs. Supervised learning is a crucial step for training discriminative AI models. Classification algorithm assigns test data into specific categories. Data about cats and catness to find cats in photographs, literature, and even in conversation. Regression is a method for understanding the relationship between independent variables of features and a dependent variable or outcome. Outcomes can then be predicted once the relationship between independent and dependent variables has been estimated. An example, using past acceptance of emerging technology. Let me see, what was he doing there? Oops. Go back. I'm sorry, I'm getting ahead of myself. So we've talked about generative AI, ChatGPT. Don't know if you know, ChatGPT stands for Chat Generative Pre-trained Transformer. Generative AI can create new things like text, images, or music by learning patterns from existing data. Computers can go through enormous amounts of data at high speeds, including the speed of light, so they can categorize data very quickly and go through extremely large volumes of data to do this. They do this using something called edge computing. The two models of generative AI are large language models, or LLMs, and visual language models, or VLMs. A transformer is a powerful neural network architecture that excels at analyzing and manipulating sequences of data, especially useful for tasks like machine translation and text generation. LLM is the basis for ChatGPT or Google's Gemini project. Transformers are use probability to assign scores to different options, which like which word was likely to come next in a sentence. We've seen that in our text now with the latest versions of the OS that's coming out on our phones. They do this by employing a softmax function that outputs probability distributions. This is deep into the math of computer science, and we're not going to get into that at all. Transformer is deep learning model, analyzes images by breaking them into parts, focusing on important aspects through self-attention, like focusing on specific words in a sentence to understand the overall meaning. It's language to image or image to language. And pixel relationship and probability are part of this vision transformer. Still has some likelihood of being incorrect. AI isn't everything we think it might be yet. Unsupervised training is like giving a child a box of toys and letting them just explore it at will and organize them on their own. The model analyzes unlabeled data, finding patterns, similarities, and structures without any pre-designed categories or instructions. It uncovers hidden relationships within the data all by itself. Machine vision is essentially giving machines the ability to see and understand the world around them. It uses cameras, like we've seen earlier today, to capture images or video and analyzes this data using computer algorithms. Machine vision equips machines with the power to perceive their environment, similar to how humans use sight. Cameras capture the images or videos, which are then processed by algorithms to extract that information. Keep going. Based on the extracted information, machines can now make decisions, take actions, or trigger pre-programmed responses like image settings in the camera. Image finishing in a meeting or training session and instantly receiving comprehensive AI-generated summary with action items, key decisions, and notes from the session. AI tools are already making this a reality, saving teams hours of manual note-taking. Cameras and technology can explore beyond human perception. Prime example is the Webb telescope. Using infrared technology, we see things we've never been able to see before. Let's take a look at a life-saving scenario. Imagine an advanced camera in a hospital emergency room. It's driven by artificial intelligence, and the camera sees the patient and can tell by the infrared signature of the body heat what the patient's temperature is. It can also see micro movement of the patient's eyes, note the chest movement associated with irregular breathing. The AI program can include many variables, even from other machines attached to the person in the ER. It's all inputted by receiving what the trauma team may even be able to determine and help the trauma team determine a prognosis and need for intermissions. In this scenario, AI can efficiently and accurately support initial diagnostic and therapeutic decision-making, helping to save lives. It can even take the conversation between doctors and nurses and other people in the ER and analyze that to help come up with what needs to happen next. These things need AI input, often faster than human can gather the data to deliver information to the AI program. The camera has to work in a range far beyond human vision, and the machine doesn't have our limitations as far as our human eyes. The amount of data that such an advanced camera, this technology is currently available today, by the way, is beyond what any land can support. So we're getting into edge computing. Edge computing is like AI would need to process complex data systems or streams, including high resolution images, videos from advanced cameras, and potentially large volumes of text from trauma team notes, for example. Deep learning algorithm for image analysis is computationally expensive, and real-time or near real-time needs for time-sensitive medical decisions, for instance, the AI might need to analyze and provide insights quickly. There are many AI solutions coming online, and it's the hottest topic in AV, not projection screens. But what does AI really mean for AV? Today, the amount of data that is being generated by both humans and machines far outpaces our ability to absorb, interpret, and make complex decisions based on that data. Artificial intelligence forms the basis for all computer learning and is the future of all complex decision making. AI-powered visual language models can interpret visual data such as images or diagrams and describe them in real time in an instructional setting. This could help automatically create transcripts of meetings or turn complex diagrams into understandable explanations. I've even heard that you could give a financial meeting with charts and graphs in that meeting like you always see, and AI can learn more, with a history of learning about your company, can actually help design next steps to use based on that financial data in those graphs and charts. AI forms the basis of where we go from here in the AV industry. AI has been with us for over 50 years, yet it is just now an emerging concept. What does this mean to us in AV? It means the AV professional really needs to understand a little bit about AI, what it is, and how to explain the abilities and limitations to our customers and colleagues. We need to understand precisely how it will impact our projects and our lives. When we understand these concepts, we become an asset and a value to our clients and our employers. Some of the things that we've talked about today, I won't go over them again. And that's it. Thank you very much for your time today. Hope you kept up. It was a lot.